We skipped 11.3 the first time around to keep the focus on prisms and cylinders, but we're going back to surface area for 11.3, this time with a couple different shapes, pyramids, and cones. So our goal is still going to be the same for surface area. We're going to find the sums of all the surfaces in that figure, and we're going to end up having some formulas to find that. But if we're going to talk about a pyramid in the first place, that's a polyhedron, where one face that we call the base can be any polygon, and the other faces, which are the lateral faces, are triangles that meet at a common vertex called the vertex of the pyramid. So same kind of idea if we look to our pyramid figures as our prisms. They still have a base. Well, actually our prisms had two bases, but now we just have one base, still have lateral sides. This time they just meet at a vertex instead of the other base. So we're still going to name the pyramid by the shape of the base, just like for prisms. And we still have altitudes, and for a pyramid, it's a perpendicular segment that goes from the vertex, so going from the top of the pyramid to the plane for the base. So the length of the altitude is what we call the height of the pyramid. Regular pyramid is a pyramid whose base is a regular polygon and whose lateral faces are congruent isosceles triangles. And the slant height is the length of the altitude of a lateral face of that pyramid. So we didn't have slant height before. And that's just the measurement going up the side of that triangle. So you can think if I was going up the side, that's the same thing as the height for that triangle on the side. Everything else we've kind of seen a little bit in prisms. We saw lateral faces, we saw lateral edges, we had an altitude, we had a base, we had base edges, and we're still going to name them similar too. So based on whatever the base is, base would be a hexagon, so we'll call this a hexagonal pyramid. For this square pyramid, again, we see that because the base is a square. Also, in this book, we're going to assume that a pyramid is regular unless we see otherwise. So we have two regular pyramids, not going to be an oblique pyramid unless we actually picture it. So the lateral area of a pyramid is the sum of the areas of the congruent lateral faces, just like for a prism. We add up all the sides. We can find the surface area of a pyramid by adding the area of the base to its lateral area. So that makes our formula a little bit different for surface area of a pyramid than it was for prisms. And again, for lateral area of a pyramid, that would be all the sides. So since our sides are triangles, that would be 1/2 perimeter times the slant height. Kind of like when we had perimeter times height before, but again, since I'm not using rectangles for the sides, I have to do 1/2 perimeter times slant height to get the 1/2 base times height formula. And also for surface area, the difference here is that we're still taking lateral area, but instead of adding two bases, a pyramid's just going to have one base. So that's lateral area for all the sides, plus the bottom, that would give us our surface area. And again, capital B, just like what we saw from before, that will still stand for the area of the base, not just one side of the base. So trying some practice with that, finding that surface area. Again, that will be lateral area plus the base. And lateral area is always going to be the same formula, so we can always reduce it to this for the surface area. The base could be different depending on your figure, so that's going to have to stay at capital B. But the easiest way to find the surface area is to break those parts down and see if we can find those individually. So if we're going to find lateral area, we're going to need a perimeter first. So the perimeter is, again, referring to the perimeter of your base. If I have a hexagon with a side length of 6, and it's a regular hexagon, I can do 6 times 6 sides, and that should give us 36 for a perimeter. We're also given the slant height, this perpendicular segment up the up the side of this pyramid. That would be a length of 9. And also for our base area, this is where we have to go back to our rules from chapter 10. If we're trying to find the area of that base, which is a hexagon, I have to use 1/2 apothem times perimeter because that's a regular polygon. So if I look at that side length of 6, again, I can split that into 3 and 3 if I'm looking for my apothem in that right triangle. And we can just remember that to find that middle angle of the triangle, I can take the 360 divided into the number of sides, cut that in half. This is where we get our 30 from. It's still a 30 from where we're doing our hexagons before. So if that's a 30, 60, 90, again, that side length will be a 3. So if I take the short side times rad 3, our apothem is going to be 3 rad 3 again. So for the base area, that's 1/2 apothem times perimeter. We just found the apothem from breaking down that right triangle, and we found the perimeter earlier, and that should all come out to 54 rad 3 for the base area. So again, going back to surface area, we're just substituting what we've already found. 1/2 times the perimeter times the slant height, and also adding in just one base, not two bases. That should come out to about 256 if we round that to the nearest whole number. Trying that again, this time we don't have a drawing, but we do have a description, which is still enough to work off of. We have a square pyramid. The square is important, so we're going to have to remember that. Base edges this time have a length of 5, and the slant height has a length of 3, and those are both in meters. So it's still the same formula, lateral area plus the base. Lateral area in this case, again, we have to find a perimeter, so that's a side length of 5. A square would have 4 sides, so the perimeter would be 20. And also it just tells us the slant height, that would be 3. If we want to find the area of that base, since it's just a square, it will be the side length times itself, so that area should be 25 for the base. And now that I know all 3 values, I can substitute those in, and my surface area should come out to 55 square meters. You do want to make a correction on this next sentence. When the slant height is not given, we have to find that, we have to calculate that before we find the lateral or surface area. And that's what our next question focuses on. We have a pyramid drawn out, and we have to use the dimensions to find lateral area, but if we look at that lateral area formula again, 1/2 perimeter times slant height, we can find the perimeter, but we're going to have to take a little work to find the slant height because it's not labeled for us. So perimeter should be easy enough. If I know it's a square pyramid, and if I know a side length is 30, I can do 30 times 4 sides, and that gives me 120 for a perimeter. For the slant height, I'm going to have to use the actual height of that pyramid, and I'm going to have to use half the length of one of those sides of the base. So if I look to that right triangle that they're picturing, kind of cutting through the middle of that pyramid, the slant height would go along the side there, so that makes a right triangle, with one leg being 36.4, the height, and the other leg would be half the length of that base. Again, it's not 30 because I'm not going all the way across. I'm just using 15 for the bottom side of this triangle. And if I have 2 sides of a right triangle, I can always find the third by Pythagorean Theorem. And since slant height is the hypotenuse, I'm going to take the sum of the squares of the other 2 sides, add them up, and that should be the square of my slant height. So if I work through Pythagorean Theorem on that, we're just going to hold on to this answer. I would add those 2 together and take a square root. And for my slant height, if I substitute that value back in, again, the lateral area is just 1/2 perimeter times slant height, and that should come out to about 2,362 if I round that to the nearest whole number. So you're going to be using that a lot with Pythagorean Theorem. If I ever have 2 sides of a right triangle, I want to be good at a squared plus b squared equals c squared, because that should tell you a slant height. So let's try this again with hexagonal pyramid. Again, we're just looking for lateral area, so we're not adding the base in. This takes a little bit less work because we don't have to do that area of the hexagon. Lateral area is 1/2 perimeter times slant height again. So perimeter, if I know that each side is 36, if I know I have 6 sides for a hexagon, I multiply those and I should get 216 for a perimeter. And for slant height, we're using this right triangle again. We know that the apothem would be 18 rad 3, so that would be one leg of your triangle. And we also know the height that was given was 42. So if I take a squared plus b squared equals c squared and solve that for the slant height, we're just going to hold on to that as a square root. So if I take my slant height, substitute that in, we knew the perimeter is 216. 1/2 perimeter times slant height should come out to about 5649, and that would be square feet. So other than pyramids, we're also going to be looking at cones. So that's a solid that has one base still and also a vertex not on the same plane as the base. So very similar to your pyramids. Except this time the base of the cone is a circle. So kind of like the connection between prisms and cylinders, they're both very similar, except the cone has to have that specific base that's a circle. So in a right cone, the altitude is a perpendicular segment that goes from the vertex to the center of the base, so going straight down. The height is the length of that altitude, and the slant height is the distance from the vertex to any point on the edge of that base. So it's drawn in along the sides, but since that's the same all around, you can kind of picture that slant height being anywhere. And we're always going to assume our cones are right unless we draw that otherwise or state it otherwise. So slant height again going up the side, height or altitude going straight down, vertex at the top just like a pyramid, except this time the base is always a circle if it's a cone. So lateral area is half the circumference of the base times the slant height, so kind of like what we saw before with 1/2 perimeter times slant height. The formulas for lateral area and surface area are also similar to our pyramids. So for lateral area, again with our pyramid, it was 1/2 perimeter times slant height. Only difference here for a cone is that your perimeter is a circumference because we're doing a circle. So 1/2 circumference times slant height. We can simplify that down to just pi times radius times slant height, because half of the circumference is just pi times the radius. And also for surface area, same thing as with a pyramid, we're going to take the lateral area and then just add the base onto it. Nice thing being here, the base is always a circle, and that capital B again is still base area. So let's try that a little bit with some cones. We're looking for the surface area in terms of pi. Again, that's lateral area plus a base area. And just like with cylinders, you can always simplify that formula down because they're always using circles. Lateral area will always be pi times radius times slant height. And your capital B, your base area, is always a circle, so that's always going to be pi r squared. So looking for our pieces to substitute, we look and see that we have a 15 for a radius that's given. We're also given 25 as a slant height. And again, if we were to find capital B, the base area, that's pi r squared, so pi times 15 squared, that should be 225 pi. Substituting those back in, our radius, our slant height, and our base area, all you have to do is add those together. We can add these because they're like terms. They both have a pi. That should come out to 600 pi. So we have our answer in terms of pi. Next question, not drawn, but we should be able to find it still. We're given a radius and a slant height, using that to find surface area again. And remember, those are the only two things we're going to have to use in that formula are a radius and a slant height. So if I substitute those in directly, radius is 16, slant height is 28. Also remember to plug in the radius squared for our base area. That should combine to give us 704 pi, and that would be square meters. So last question, they're not telling us exactly what to find, but we can use some reasoning to figure out they're using lateral area. In our lab experiment, we're using our filter that's conical, so it's forming a cone shape. And we're going to have to decide how much filter paper do we need to line the funnel. So this would be in terms of lateral area because, again, if I'm making a funnel, I don't want to cover the top of it. I'm not going to have a base for that cone. I'm just going to have the sides of that to make a funnel. So if I'm trying to find lateral area, again, that's just pi times radius times slant height. And if the diameter here was 80, that means our radius would just be half of that. So we know our radius is 40. For our slant height, we're given the height of that cone is 45. And this is where I want to look to make another one of those right triangles. If I'm using the radius as one side of the triangle, so we're kind of picturing half of our cone here, and 45 as the height, the slant height is still just that hypotenuse. So if I do another Pythagorean theorem, a squared plus b squared equals c squared, we get our slant height to be the square root of that sum, 3,625. And if I know those two values, again, last step is just substituting those in. Pi times radius times slant height should come out to about 7,566. So make sure we have these complete, and we'll get ready to do some practice on this in class.